Now I'll describe the incorrect recurrence relation that I try to use in class, or I try to write down in class, and we found a bug in that. Um, Feel free to skip to a later part of the video where I'll describe the correct recurrence relation, but I thought just going through what went wrong in this recurrence relation might be useful, at least for some of you. So I'll describe the incorrect reconciliation that we try to write in class before I describe the correct reconciliation. Feel free to skip ahead. So suppose we're trying to write a recurrence for Tij, which I recall is the min-cost triangulation of the section Ij. So for simplicity, let's just say our I is 1, it's here, and j is 7, which is here, which means our section is given by the following. So you have, this is the section that we're trying to find a min-cost triangulation of. So we need to break up the optimal triangulation of this section Tij into smaller pieces, the optimal triangulations of smaller pieces. So the idea that we were pursuing in class is, let's look at the edge I plus 1. So in this case, it is just the edge 1, 2. This is the edge I plus 1. The edge I plus 1 has to be part of some triangle. And so let's see what the third vertex of this triangle is. So let's say the third vertex of this triangle is K, and we don't know where it is, where the third vertex is in the optimal triangulation, but let's just say K is somewhere here. So this is K. And then the idea was, okay, let's now see what are the pieces in this triangulation. There is the triangle I plus 1, K, and then we have one piece on the left which is given by this polygon, and then another piece on the right which is given by this polygon. So we write the min cost triangulation of the section 1, 7 to be the cost of the triangle 1, 2, 5, which is really our I plus 1, K. So far so good. But then we'll get two different polygons on the left and the right. Well, let's look at the first piece. It's the polygon 2, 3, 4, 5. The min cost triangulation of this one. And the other polygon we get is T 1, 5, 6, 7. Notice that 2, 3, 4, 5 is a section. So that's good. But the other piece that we have here, which is 1, 5, 6, 7, it's not a section. Well, because it has two jump edges. So let me mark them. Note that 1, 7 was a jump edge that we had originally in our section. But then we ended up with another jump edge, which is 1, 5. So we have two jump edges in this polygon. And recall that every section had literally just one jump edge. You would follow the edges of the polygon up to a point and just do one jump. Here there are two jump edges, so this is not a section. So we ended up breaking up a section into polygons which are not sections, and since we have only sections to be our subproblems, this recurrence relation doesn't work. So we need to be clever about breaking up the subproblem in a way so that we end up with only the subproblems that we have. So if we start out with having subproblems to be just sections, we should break them in a way so that we only end up with sections.